Now that we know a little bit about Newton's first law, let's give ourselves a little quiz. And what I want you to do is figure out which of these statements are actually true. And our first statement is, if the net force on a body is 0, its velocity will not change. Interesting. Statement number 2, an unbalanced force on a body will always impact the object's speed. Also an interesting statement. Statement number 3, the reason why initially moving objects tend to come to rest in our everyday life is because they are being acted on by unbalanced forces. And statement 4, an unbalanced force on an object will always change the object's direction. So I'll let you think about that. So let's think about these statement by statement. So our first statement right over here, if the net force on a body is 0, its velocity will not change. This is absolutely true. This is actually even another way of thinking about another way of rephrasing Newton's first law. If I have some type of object that's just traveling through space with some velocity, so it has some speed going in some direction, and maybe it's deep space, and we can just for purity assume that there's no gravitational interactions. There'll always be some minuscule one, but we'll assume no gravitational interactions, absolutely no particles that it's bumping into, absolute vacuum of space. This thing will travel on forever. Its velocity will not change. Neither its speed nor its direction will change. So this one is absolutely true. Statement number 2. An unbalanced force on a body will always impact the object's speed. And the key word right over here is speed. If I had written impact the object's velocity, then this would be a true statement. An unbalanced force on a body will always impact the object's velocity. That would be true, but we wrote speed here. Speed is the magnitude of velocity. It does not take into account the direction. And to see why the second statement is false, you can think about a couple of things. And we'll do more videos on the intuition of centripetal acceleration and centripetal forces, inward forces, if this does not make complete intuitive sense to you just at this moment. But imagine we're looking at an ice skating rink from above, and you have an ice skater. This is the ice skater's head, and they're traveling in that direction. Now imagine right at that moment, they grab a rope that is nailed to a stake in the ice skating rink right over there. We're viewing all of this from above, and this right over here is the rope. Now what is going to happen? Well, the skater is going to travel. Their direction is actually going to change. And they could hold on to the rope, and as long as they hold on to the rope, they'll keep going in circles, and when they let go of the rope, they'll start going in whatever direction they were traveling in. When they let go, they'll keep going in that direction. And if we assume very, very, very small frictions from the ice skating rink, they'll actually have the same speed. So the force, the inward force, the tension from the rope pulling on the skater in this situation would have only changed the skater's direction. So an unbalanced force doesn't necessarily have to impact the object's speed. It often does, but in that situation, it would have only impacted the skater's direction. Another situation like this, and once again, this involves centripetal acceleration, inward forces, inward acceleration, is a satellite in orbit, or any type of thing in orbit. So if that is some type of planet, and this is one of the planet's moons right over here, the reason why it stays in orbit is because the pull of gravity keeps making the object change its direction, but not its speed. Its speed is the exact right speed, so as it travels, so this was its speed right here. If the planet wasn't there, it would just keep going on in that direction forever and forever. But the planet right over here, there's an inward force of gravity, and we'll talk more about the force of gravity in the future. But this inward force of gravity is going to accelerate this object inwards while it travels. And so after some period of time, this object's velocity vector, if you add the previous velocity with how much it's changed, its new velocity vector, now this is after it's traveled a little bit, its new velocity vector might look something like this. And it's traveling at the exact right speed so that the inward force, or so that the force of gravity is always at a right angle to its actual trajectory. And it's the exact right speed, so it doesn't go off into deep space, and so it doesn't plummet into the earth. And we'll cover that into much more detail. But the simple answer is unbalanced force on a body will always impact its velocity. It could be its speed, its direction, or both, but it doesn't have to be both. It could be just the speed or just the direction. So this is an incorrect statement. Now the third statement. The reason why initially moving objects tend to come to rest in our everyday life is because they are being acted on by unbalanced forces. This is absolutely true, and this is the example we gave. The reason why if I take an object, if I take my book, and I try to slide it across the desk, the reason why it eventually comes to stop is because we have the unbalanced force of friction, the grinding of the surface of the book with the grinding of the table. If I'm inside of a pool, and even if there's absolutely no current in the pool, and if I were to try to push some type of object inside the water, it eventually comes to a stop because of all of the resistance of the water itself. It's providing an unbalanced force in a direction opposite its motion. That is what's slowing it down. So in our everyday life, the reason why we don't see these things go on and on forever is that we have these frictions, these air resistance, or the friction with actual surfaces. And then the last statement, an unbalanced force on an object will always change the object's direction. Well, this one actually is maybe the most intuitive. We always have the situation, if I have let's say I have a block right over here, and it's traveling with some velocity in that direction, 5 meters per second. If I apply an unbalanced force in that same direction, so that's my force right over there. If I apply it in that same direction, I'm just going to accelerate it in that same direction, so I won't necessarily change it. Even if I were to act against it, I might decelerate it, but I won't necessarily change its direction. I could change its direction by doing something like this, but I'm not always necessarily changing the object's direction. So this is not true. An unbalanced force on an object will not always change the object's direction. It can, like these circumstances, but not always. So always is what makes this very, very, very wrong.